I think, and I found a lot of this information from reading your many comments on the forums over the many years that I've been following. And I remember you said that your design goal many years ago was to reach 1 million taps.
Yes.
And you felt that once you reach that 1 million the taps, that is the approximate processing power of the brain to comprehend.
That actually wasn't my position.
Oh, it wasn't? Okay.
No, it was the going back to the 1980s, when I was studying electronics and I studied the mathematics behind sampling theory. I also studied psychoacoustics. Nothing to do with my degree. I just went into the psychology lab and read up all the textbooks on psychoacoustics. One of the things that was really, really important from the psychoacoustic point of view was transients and the timing of transients.
Yeah.
And that perceptually is vital. We hear pitch, we hear timbre, soundstage. Most of those cues come from the timing of transients. And when I then looked at the theory behind sampling theory, which is what digital audio is all about, it's all about sampling theory, I realized that you need to reconstruct the timing of transients properly. And to do that, you would need to have a sync function filter. And a sync function filter, as you double the time period, you have to value the coefficients. So the coefficients never get to zero, they just converge on zero.
Yeah.
So you have to keep doubling the size of the filter to make it more accurate. And it was easy to do a little calculation of, let's say you want 16-bit performance, and 16-bit performance to me sounded like a good idea because we've got 16-bit data.
Yeah.
Let's reconstruct it to 16-bit accuracy. To do that, you would need more than 500,000 taps. So you're looking at 1 million taps. It wasn't based upon listening tests. It was just based on the idea we want 16-bit accuracy, which sounds like a good idea. Then you must need 1 million taps. My actual way of working with this has been on increasing the number of taps.
I know you mentioned that once you don't get any audible improvement from doubling the taps, you felt that your job was kind of done.
Well, exactly, yeah. Once we get to a stage where you double it and you can hear no difference in sound, then we've hit the limits. So one of the things that I wanted to investigate during COVID was what those limits actually are. So I've been working on the scaler to suit Dave, to match Dave, and that's a lot more taps. But it's not just about taps, it's about reconstruction accuracy and trying to figure out why, for example, on the WTA algorithm, you have to construct the algorithm or fine-tune the algorithm to within 10 parts per million on the windowing function. I'm getting a bit technical now, but the windowing function is the way you create your filter coefficients. And it was really strange that my windowing function has got 5 variables, and that those different variables change the nature of the windowing function at different parts of the curve. And on each variable there's a sweet spot. So you listen to it and adjust it and listen to it and adjust it, and eventually you find that there's an optimum point. And that optimum point was an accuracy of about 10 parts per million, which is an incredible level of accuracy. So what I wanted to do was to find out, why was this thing so sensitive? What was actually going on? And I discovered that reason, what was going on sonically. And as a consequence of that, I found out how many taps we actually need before we no longer need to worry about it. and it turns out to be billions upon billions upon billions of taps. In fact, the number was 10 to the power of 17, and we can't even imagine those kind of numbers. So it's easier to imagine it in terms of how long a length of period do we need. And you need 2 billion years added to a file, and 2 billion years at the future and 2 billion years in the past. So 4 billion years for a WTA function to work. So that, of course, is never going to happen, because you'd never be able to do that. So I managed to come up with a way of improving that, and that's a conversation for when the new scaler comes out, because it's really, really interesting what's actually happened.
Okay.
So it wasn't about 16-bit. That was the ultimate. It was about, let's get to 16-bit and hear the difference and see how much has happened. What's also happened from the psychoacoustics point of view is that if you look at all the textbooks, they'll say that the brain works to 4 microseconds in terms of the interaural delay, the delay between the left and the right ears. That resolution is 4 microseconds. Recent research has shown that actually there's no limit. The brain can detect almost 0 time differences between the left ear and the right ear, because they've looked at the physiology of the interaural delay. Now that's interesting, but it's also interesting that the listening tests that I've been doing, the tiniest transient reconstruction error becomes audible. So we have to go to crazy numbers to reconstruct, or crazy levels of accuracy, so that we can get the best sound quality. So it's turned out to be a much more complicated and much more difficult problem than I ever expected going back to the 1980s, when this problem first came about.
So it looks like we have then 2 products coming I know there's a reference
a reference DAC
over beyond Dave, and looks like we have a M scaler too.
And it's not an M scaler 2 because it's priced at the same price point as Dave. Okay. I don't know what the price is going to be, because I just design to the performance level, and then Chord works out the bill of materials cost and then works out the price from that. So it's going to be around the same kind of price as a Dave, but it's packed with lots of FPGAs and this new technique. So yeah, it's quite exciting.
Any of this should be kept private?
No, I wouldn't be talking to you. You can talk about it. Yeah.
Okay. Because I think everybody is asking questions, and you've been asked this many times, about the Dave is I think 7-8 years old, when are we going to have Dave 2? And you had an interview earlier this year, right?
So I haven't started work on the Dave replacement yet.
Okay.
My focus is the new scaler and the Ultima DAC. So when the Ultima DAC is finished, then I can start looking at other projects, but we haven't started to work on Dave replacement yet.
Okay. So what do you think about some of these software solutions, because I have friends that use their PCs running software, and they'll say that I can get much more than 1 million taps, I can do this, I can do that.
Well, the key, I was the first person to start talking about taps and the importance of large amount of taps. But it's not actually about the taps, it's about the algorithm itself. And that's why I was talking about 10 parts per million accuracy on these different 5 variables for the windowing function. To get that level of performance, there's been thousands of listening tests to optimize these different variables. And when I optimized one, I'd have to go back to the other variables to check that they hadn't changed. So it was a real pain in terms of getting it right. And I had to listen to lots of different factors. So I've got 4 or 5 different tracks that I use to listen to different parameters. So when you change one part of the windowing function, it will have a different impact to sound quality compared to other parts.
And do you think you'll be able to actually upload the revisions to the algorithm to the existing products?
That's technically possible, but it's not something I've been approached about or done. It would be a case of I'd have to license the algorithm to these guys, and that would be a business decision. Of course, the downside to doing things on software, particularly PGB, is you can't do it real time. The scaler you can do real time. And that's really important when you're streaming. It's also very important for when you're using video. And I use my scalers for video, and that really improves my enjoyment of home theatre. But by using, again, in my case, I'm streaming, and I'm using the NVIDIA. I've forgotten the name of it's called, but that allows a 1 second delay in the video itself, so you can use an M scaler with it, and that makes a big difference. So now, I've listened to the original files for the PGB, and I didn't like the sound of it. It didn't sound anything like the M scaler, and they're using apodizing filters. Apodizing is not the right approach in terms of transient reconstruction. Now, things have moved on since, and I've not heard the latest version, so I can't comment on it, what the latest version is like, but the original version I heard was nothing like the sound of an M scaler. An HQ player, I've got no experience on, but that's for other consumers to try.
Okay, I think your latest thoughts on power supply is that you think that the car battery will be
the car battery is the best.
Yeah.
Yes, if you want the best power supply, a car battery is the best you can get, because there's zero noise. It's got sub-milliohms in impedance. It's got 300 amps capability, and that is my reference point. And DACs in the past and DACs in the future are always compared against a car battery.
Yeah, because I attended one of your earlier talks, when you came down to Singapore a few years ago.
Okay.
And that was one of the questions, that was asked, and you were explaining, on why, switch mode power supplies, actually are better, than a linear power supply.
Yes, because they've got RF filters built into the input and the output.
Yep.
And the audiophile linear supplies that I've seen don't have any RF filters. And in fact, the designers normally say, don't use RF filters because it makes the sound worse. Well, to me, it makes the sound a lot better. So the trouble with RF is that it makes things sound brighter, and it gives the illusion that it's more transparent because things are brighter. You've got more details that you think that you can hear, but it's artificial flavourings that's going on. It's not real. It's actually a distortion. So when you reduce the RF noise, things sound warmer and softer and quieter. You end up increasing the volume level. You can play at a louder volume level when you reduce RF noise. It's less impressive, but it's much more natural. And I think that's one of the reasons why people don't use car batteries in audiophile terms when they really should be, using that as a reference.
Okay. What do you think about this theory, that switch mode power supplies actually pollute the whole mains line? For example, if you take a switch mode and you plug it into your wall, even when it's not connected to anything,
that is true. But in a house today, you have got
tons of that stuff.
Tons of switch mode power supplies, And on the street outside, you're looking at hundreds, maybe thousands of switch mode power supplies locally. So it's a problem. The particular issue that we're mostly worried about is random RF noise. You get random RF noise from fluorescent light tubes, and actually even LEDs themselves create random RF noise. A switch mode power supply generally just creates a regular PWM waveform. And I did a simulation study. It's called SPICE simulation, where you can simulate analog components. In this case, I was simulating some of my RF filters. If you use a switching waveform as your stimulus and you want to filter the switching waveform, it's very, very easy to make that switching waveform nanovolts, in that you just use a couple of stages of RF filters, the same kind of filters that I build into my DACs. So it's quite easy to get rid of PWM noise, switching noise. Getting rid of random noise, and if you want to go down to sub-nanovolts, is almost impossible. You need to have a filter that is 10 times more complicated, in fact more than 10 times more complicated, in order to eliminate random noise. And it's the random RF noise that causes the sound quality problems. And the reason it's random RF noise is that you get, when the noise goes into the analog electronics, you get intermodulation distortion. And if it's a random source, your intermodulation products are random, and that extends down to DC. So your audio bandwidth has got a lot of random noise, which is pumping up and down with the signal itself. If you do it with, say, a 500 kilohertz component, then you end up with intermodulation products which are 500 kilohertz plus or minus 20 kilohertz, the audio bandwidth. So it's still outside the audio bandwidth. There's nothing on the inside the audio bandwidth. So random is much, much more important, and that's what we're trying to remove. To eliminate that, you need really complicated RF filters. Something that nobody actually ever does. So, yeah. Did that answer your question?
Yeah.
Or did I get too technical?
Okay, the technical is fine, but I was just thinking, you see this, the incredible, the industry, supplying, a lot of, aftermarket, power supplies for Chord products, and people, are fighting with each other every day, which one is better than this, and all of that. So, I mean, I know Chord gets quite a lot of stick, about the switchable power supplies, that they supply. Did you think that there would ever be a market, to actually come up with a Chord power supply, especially for their products, that is better than what is already supplied? So,
what I try to do is to make it sound like the car battery. I did that with the Q-test, and in fact I was shocked when I went from 2Q to Q-test. One of the things that was happening going back, and we're talking about 2016 now, one of the things that was happening was that people were talking about better power supplies for Q-test. That had a 12 volt input, and I was shocked with 2Q when I used the car battery how much better the car battery actually was. With Q-test, I got the same performance with the car battery as I did with the switch mode power supply that we supplied with Q-test. With TT2, I had the same situation. You can't hear a difference when you're using a car battery, unless you're using an M scaler, and that's another story. So I eliminated those issues. So there's no point in supplying a better power supply with Q-test and with TT2, because the power supply, if there is a difference in sound, it's going to be sounding worse. You're adding more RF noise, which is causing you grief. So that's my philosophy. commercially, of course, it would make a lot more sense if we did a range of power supplies and you could charge a lot more money for it and all that kind of thing. But that's not the way I work. I want to solve problems fundamentally, and not to come up with solutions that people have to pay lots of money for in order to overcome it. Dave's a different story, because with Dave, this is before I was playing around with power supplies. But with Dave, it's got a huge amount of RF filters built into it, actually more so than with TT2. So I'm happy intellectually about what I did with Dave.
Okay, but the TT2, right, has a super capacitor, right?
That's got super caps, yeah. And it's also got the RF filters into it. The super caps don't help with RF noise.
Okay.
What they do is they help with the low frequency noise problems, but they don't help with RF noise, because the impedance is too high. You need to still use the specialist RF treatment that I do onto it.
Okay, because a lot of manufacturers, right, when they use the super cap power supplies, right, they'll tell you it's like as if it's like a battery supply.
It's not. It's not like a battery. It's like a battery for 50 hertz or 100 hertz, the mains harmonics, but it's once you get beyond 20 kilohertz, it's exactly the same as a regular supply. Because the internal inductance on these capacitors is quite high, and the impedance starts to rise. They're not wonderfully low impedance either, super caps. They're about 50 milliohms, so they're not fantastically low impedance. They're not like a car battery, which is sub 1 milliohm. Super caps help, but they don't solve the problem. And if somebody says, I've got a power supply that uses super caps, therefore it's perfect, it's wrong. They're not understanding what they're trying to achieve with it. And it's certainly not, it's a non-issue when it comes down to RF noise. With RF noise, particularly when you're worrying about gigahertz, and gigahertz is a major issue. Here, it's all about making the inductance as small as possible, and the tracking impedance, how you connect up the capacitors, having extremely small caps. You've got to be looking at 0.5 millimeter worth of size in terms of the capacitance itself. Otherwise, the self-inductance of the capacitor means that you're not filtering RF noise out at the gigahertz frequencies. So gigahertz is a special problem, and it was when I was looking at this random noise and the filters. It was in the gigahertz, 100 megahertz to 10 gigahertz region that I had the most trouble with. Incidentally, this filter that I've been working on has been for the Ultimate DAC, where we've got a separate power supply for the Ultimate DAC, and I wanted to have the ultimate power supply. But it's the ultimate power supply in terms of RF noise. It's still using switch mode power supplies, and it's working really well.
Okay, and probably this is the question, right, that we've all been waiting for, and that is about, right, the measurements, right, of the products, and some of the criticism, right, about the high jitter levels.
Yeah.
Right, of I think both the M scaler, right, and I think it was the Dave, I think, which they measured.
Yeah, you're talking about the ASR reviews.
And there's actually another guy who's done, right, a series of measurements, right, recently in another, right, forum, which I can't quite remember.
Golden one.
Yeah. Golden Sound.
Golden Sound. Yeah. I know him rather well. He's an okay guy. Measurements. So we've got the M scaler. You don't need to worry about the measurements on the M scaler because the jitter that's coming out of the scaler is eliminated within my DACs anyway. So I've never designed it in terms of a low jitter output. That was never what we were trying to do. It's about reconstructing the timing of transients properly. Once it gets to my DACs, you can have 2 microseconds worth of jitter and it'll have no impact at all in terms of the measured performance. Here with the M scaler, we're talking about nanoseconds worth of jitter, not microseconds worth of jitter. So to criticize the product based on its measured performance in terms of jitter doesn't make any kind of sense, because it's not relevant. In terms of Dave I've got a particular problem with, because I measured Dave and I've gotten extraordinary results. Hi-Fi News measured Dave, and they got extraordinary results. They measured it 0.00000, I think it's 4507% distortion. Actually lower than the measurements that I've got with Dave. So Dave measures, to me, better than any other DAC measurement I've seen. And yet we're seeing other people doing measurements, again with the APX 555, and getting completely different numbers. Now, I did have a situation where a manufacturer that I respect, who knows his business, he's got an AP, he was measuring a TT2 and the M scaler and was getting a horrendous performance. And it was really, really bad. And I said to him, this just isn't right. You know, you must be measuring ground loops within your setup. So he stripped down his lab, redid everything, and it then measured perfectly. So how you set up your lab, particularly the APX 555 is incredibly sensitive to ground. You'll get different measurements if you use different laptops. If you're grounding it differently, you'll get different measurements. Of course, when I set my lab up, I set it up so that my DACs work and get the lowest possible performance. It's not because I'm trying to measure it the best, it's because I'm just trying to get the measurement equipment and the DAC itself to give the best performance. It's not a case of optimizing the DAC to suit the AP 555, it's making sure the AP 555 works correctly with the DAC. So it takes a lot of time and a lot of care. So I use different laptops, and I structured my lab so that it doesn't misbehave. So I don't understand why we're getting such completely different results and why different reviews are coming up with different numbers. And it does worry me because, you know, when measurements are important to me, and I publish my measurements, and they're an honest measurement of what I've got. And when people come up with different values, different numbers, it's troubling, because the implication is that I'm lying on when I do my measurements, and that's not something I do. So yes, it is a problem.
But and I know you've been asked this question before, about objective versus subjective, right? If you design the equipment that measures really well, but in your final listening test, it doesn't stack up.
So, what do measurements tell you? They tell you how bad something is. They'll never tell you how good something is. So you can have something that measures extraordinarily well and that sounds dire. You can have something that measures kind of okay, but sounds infinitely better, or so much better. I'm going to take valve power amplifiers. Valve power amplifiers generally measure a lot worse than solid state power amplifiers. But you take the average solid state power amplifier and the average valve power amplifier, the chances are the valve power amplifiers will have better sound staging, better depth, sound more musical and more emotionally involving, even though they'll measure distortion will be 10 or 100 times worse. That's not to say that if you then take that valve power amplifier and reduce the distortion by 100 times, you will get better sound quality, so long as you don't screw up anything else. So measurements need to be taken extremely cautiously. because they really just tell you how bad something is. Is this not fit for purpose? Is the way I tend to look at measurements. Measurements are very important to me because it's kind of a game in that you want it to sound good, obviously, but measurements are also important because they can indicate problems in other areas that you haven't addressed. Sound quality listening tests is a reality, and it's the most important reality. Objective measurements, so long as you're carefully doing it and you're doing the right kind of measurements, is also important because they'll tell you things that are wrong with the product and things that you need to improve. But it's got to be done correctly, and it's got to be done with the right type of measurements, because conventional measurements don't tell you very much on what's going on.
And do you think there are a lot of parameters that they've not yet discovered that are actually important, but we're not measuring?
There are things that I've heard that are minus 350 dB, which I know exists because I've done digital simulations, and then you play with it and make it better, and you can hear the difference. So the ear and the brain can perceive errors that are impossible to measure with analog test gear. You can only measure it with digital test gear, and the ear and the brain is so horrendously sensitive. So you measurements can't tell you a great deal because they won't tell you about these really fine problems. So noise floor modulation, something that's very big for me, and I always claim, and it's true, that there's no measurable noise floor modulation with any of my DACs. There's still some residual noise floor modulation, and it's still audible. And these non-measurable noise floor modulation effects will change the warmth and the smoothness. So when you're talking about power supplies, a power supply making it sound warmer or whatever, then you're looking at situations which are well below measurable limits, but you can still hear the effects. When you're playing around with USB cables, with digital data it's still perfect, but you can hear differences with different cables, like going from optical to USB cable, you'll hear a difference. That's down to noise floor modulation, which you'll never be able to measure because it's just too small. Listening is the most important thing. But having said that, there's problems with listening tests because audiophiles often get it wrong, that they'll prefer a distortion or they'll prefer an aberration. What I'm trying to do is to close the gap from live unamplified sound to reproduced sound, and at the moment the difference is enormous, and I'm trying to close that gap, and that means looking at measurements, and it means looking at listening tests, but doing your listening tests in a very controlled and analytical way, a very careful way, because it's so easy to make a mistake when you're doing a listening test. Confirmation bias, placebo, these are things that all really do happen, and you've got to be a very careful neutral observer when you're doing your listening tests.
Yeah, I agree.
Yeah.
I have a lot of interesting stories about that. I remember I was experimenting with this tweak, right, and I was telling myself how fantastic it was. And then one day I went to check and I realized the tweak had fallen out of the system.
Yeah. It's very easy. It's very easy to fool yourself.
Yeah.
I've made listening tests mistakes in the past. What you have to do is to reevaluate and redo tests that you did maybe 4 or 5 years ago, and came up with conclusions then and redo it. Some of the things that, when I have something that is impossibly small, that just makes no sense that we can hear these kind of things, then I'll do a blind listening test with my son, and ask him to describe the difference in the sound quality when I'm changing these ultra small errors, and he always comes back with exactly the same thing. Oh, the depth is better. This sounds warmer, and exactly the same things that I've already assessed before I've done the test. And then I'll repeat these tests, doing different things in different areas. But several months later, I'll do the same kind of test, and it always comes back with the same answer. So I know these things are consistently true, these very, very small differences.
Is your son an audiophile by any chance?
He's studying sound recording at Surrey University. He's doing the Tonmeister course. So he plays the guitar. When he does his listening, he'll actually come up with things that are different to me. So he'll often say, "Oh, that instrument's out of tune. The pitch is wrong," and I'll know that something's not quite right, but he'll know immediately that it's out of tune, pitch is wrong. But I've trained him so that when we talk about instrument separation and focus, when we talk about soundstage depth, when we talk about detail resolution, these are things he understands, and he'll communicate in the same language that I communicate in, because that's important, that your description is accurate, that you're observing the same things and you describe it in the same way. That's why I tend to ignore things on headphone when somebody says, "I've listened to this and it sounds better." You ignore that comment. If somebody says, "I've listened to this and this is better and that's better and this is worse," and gives it an accurate a description of what's going on in the sound quality, then that is something that you can treat with a little bit more authority and a little bit more care. When somebody just says it sounds better, then it probably doesn't.
My wife and my daughter are my guinea pigs, but because they're not audiophiles, often when I'm doing the sound experiments and I say, "What do you think?" they'll tell me it sounds better, it sounds worse. But when you probe, they will have things like, "Oh, I don't like it because the sound is thin," or there's no body, or it's very harsh sounding, or it's grating on my ears. It's a bit like when you ask them to drink wine.
Yeah.
It's nice or it's not nice.
Yeah. No, that's a benefit of training Daniel, because he'll come up with objective answers in the same way that I'm doing. But it is interesting to get non-audiophiles who don't understand the language to come up with a reaction. I had an interesting case with the M scaler, and they came back and said it sounds slower when the M scaler is working, and they were right. It did sound slow, but I didn't think of it in terms of tempo. What I thought of it was it sounded disjointed and mechanical, in that things were jerking from one point to another point, and that the music didn't have the right sense of natural flow. But it was exactly right that it actually sounded slower, and it sounded slower because you haven't got this mechanical jerkiness to the rhythm, which tends to make you think it's sounding faster than it actually is. So it's often very good to get a non-audiophile to listen to your gear.
I also noticed that when you ask a lot of audiophiles, when they hear natural sounds with long decays, they tend to perceive it also as slower. Because they're used to hearing these very fast transients with almost no decay at the end.
Yes.
Stop start.
Yeah.
They say that sounds fast. That it's got good rhythm and pace. So when they listen to something that sounds natural, it is quite funny that often when you go to, let's say, a classical concert with them, and they'll tell you the imaging is off, it sounds slow, there's no precision to the sound, my hi-fi system is better. I say, wait, let's hold on a second. And then you talk through And then you realize that actually it's because they're so used to like listening to the
Yeah.
hi-fi setup
Yeah.
that is the reality.
Yeah. When you're listening to a classical concert, it's important to be close to the orchestra.
Yeah.
If you're listening in the 100th row, things are just a muddled mess.
Yeah.
And you've got to be in the 5th row, or I tend to find the 5th row is probably the best. But the closer you get, the more accurate the imagery becomes.
Yeah.
The other problem is a lot of concerts have got sound reinforcement, and you don't know it. It's there, and it is so discreetly done. But and that's a real pain. That's why when I talk about listening to sounds, it's unamplified. That doesn't mean listening to your local orchestra in a concert hall, because they often just using sound reinforcement. The minute you put sound reinforcement in, unless you're listening on the front row, you're just hearing a mess. And that's part of the problem. People don't know what real sounds like. You know, chamber orchestras are really good because they're never reinforced and you're very close to it. So yeah.
I went for an executive training once where like the local orchestra invited us to sit among the sections.
Yes.
And it was very interesting, right? Because when we sat among the violinists and when they were conducting, we can't hear anything actually except for the lead violinist.
Yeah. Yeah, it's very practice sessions are really good because you get to hear how music is made. And it's really interesting. I've been doing my own recording sessions, so I'm developing an A to D converter using pulse array, and what I want to do is to be able to go from microphone to headphones or loudspeakers and control everything in that gap, in that chain, and you'll know what the original sound was sounding like. And you can hear the reproduced sound, so you can tell where the deficiencies are throughout the whole chain. So we've been doing a number of different recording sessions. Fortunately, in the same church every single time we've been doing it, so that you build up a knowledge of the church, or the sound of the acoustics. And yeah, the practice sessions are really good. Yeah.
I think the last question I have for you today, right, is about your early days, right, in Deltec.
Okay. Yeah.
I know it's a company that you set up, right, just out of universities, and I know the world was very different then.
Sorry, the
world was very different.
The
then.
world was very different. Oh yeah.
Yeah.
We didn't have FPGAs.
No. And my local dealer actually stocked DBA products, and I remember they came in a cute little shoebox size.
Yes.
Component. And I know the company eventually folded, but going back would you have done anything differently?
I would have had a business partner that knew what he was doing and had some capital. Because basically I ended up running the whole company myself, doing design work, manufacturing, marketing, sales, accounts, everything, and no money. That is a nightmare. You have to specialize in life in what you're good at doing, and running a business is actually not an easy thing to do. It's a very, very difficult thing to do, and so that's probably but you can't rerun the clock. And there's lots of accidents in life where your path takes a different route. I can remember a conversation I had with when I went to college. I had a choice of doing maths and further maths at A level, and I ended up doing AS level electronics and maths, physics and chemistry. If I'd done the further maths option, I would have ended up going to Southampton University rather than Cardiff University. And I can imagine Southampton I would ended up being in academia for the rest of my life. And so, things just happen and you bump into somebody and that changes your whole life. I mean, I bumped into John Franks by accident in Vegas, and that completely changed my path. I bumped into somebody and then had a successful career in semiconductors, selling my IP to semiconductor companies for 14 years. Again, that was just an accident that things happen. So you can never go back. You have to remember the mistakes that you made and try not to make the same mistakes again. But the important lesson I learned was to focus on what you're good at doing, and to just concentrate on that, and just to keep going and keep going and keep going. If you've got self-belief and you've got the foundations behind that self, it's pointless having a self-belief when you don't really have the abilities. You've got to have the abilities as well as the self-belief. If you keep going, things will happen. But I mean, now I'm really successful. Chord is very successful, but I spent a lot of my life in poverty, just with this dream of making better sound quality. But you forget the 20 or 30 years of poverty quite quickly when you get older.
But I think all in all, I think there are many audiophiles around the world who are actually very grateful for your work.
Oh, thank you.
Yeah, so I mean, I'm a very happy writer user. So I know it's impossible to please everybody.
Sure.
Right? Yeah. So as long as you believe in what you're doing.
At the end of the day, I'm trying to please myself. All my design decisions are about getting better sound for me and trying to close the gap from live unamplified sound to reproduced sound, because it's so easy to get emotionally involved with unamplified sound, and that emotional and that musicality, that's what I'm trying to do. And if one person in the world agrees with me, that's great. If 100,000 agrees with me, that's also great. That's better, but it's about making things work for me, and I'm so fortunate that other people have seen that and latched onto that as well.
Right. That's great. That's wonderful. So let's talk about more interesting things, right?
Okay.
What dinner are they bringing you for right later?
Oh, I don't know what we're doing, but yeah, you asked about what do I eat in Singapore, I think.
Yeah.
Yes. So of course chili crab, and chicken rice.
Okay.
Yeah, I like that. But the beauty of Singapore is you can get anything you like. I was walking past my hotel and there was a Persian restaurant in there, and I don't think I've ever seen a Persian restaurant before. You can get anything you like, and the food is always good. And people take a lot of care in terms of putting things together. So yeah, I always enjoy coming to Singapore.
That's great to hear. Have some good beer while you're at it.
Yes, yeah. I drink too much beer, I think.
Have you ever gone to Brewworks?
Sorry?
Brewworks, it's a microbrewery, right? They have a branch right on the bay.
Is that the German place?
No.
I've not been there.
Yeah.
I tend to drink Tiger beer.
Okay.
But normally I hunt out microbreweries. Certainly in the US. I mean, the US used to be terrible for beer. Go back 20, 30 years, you couldn't get the beer was foul. Now they've got lots of microbreweries, and they've got decent coffee as well. But I should chase that out.
Yeah, if you have the chance. The IPA is good.
Okay, I'm not keen on IPA.
Oh, you're not keen on it?
I like golden ales.
The golden ale is very good.
Yeah, I do like. Any beer that's too citric, I'm not too keen on. Yeah,
Okay, right. That's all I have for today.
brilliant. Thank
Yeah.